Okay, welcome back, Algebra, section 6.3, elimination using addition and subtraction. And our objective here is going to be to solve a system of equations using elimination. I don't know why I put substitution there. Elimination. And it's just another method in how to solve a system of equations here. Using addition and subtraction. We actually have two sections on elimination, one with addition and subtraction, and then one with multiplication. So again, just to review, a system of equations is two or more equations. And all elimination is, again, is another strategy to find the solution to a system. And we know the solution to a system is a point, x, comma, y. It's just another method to do that, another strategy. Just like substitution, just like graphing. To do this, what we're going to do is we're going to eliminate one variable by adding both equations together. And then your answer here should be an ordered pair, x, y. We know that. That's our solution, is where they would cross on a graph, or if you substitute it in. Well, those are the previous two strategies. Here, we're elimination. We're going to eliminate one variable by adding both together, and your answer is an ordered pair. So steps to do this with elimination. The first thing we're going to do is we're going to make sure variables, equal sign, and constant are all lined up. And remember, we talked about here's where standard form comes into play. So we want to try to have it into standard form if you can. And that would be, remember, ax plus by equals c. So try to have those all lined up with your x's, your y's, and your equal signs, and your constants all lined up in order. Then we want to look for common coefficients. Common coefficients, remember, that means you want the same coefficients. If you have the same number in front of the x or in front of the y, that makes life a lot easier for elimination when you add or subtract. And then make sure that these common coefficients that we find, make sure that they have opposite signs. If they don't have an opposite sign, then you might need to multiply by -1, because if they don't have an opposite sign, multiply by -1, and then it will have an opposite sign. But you remember, you got to multiply everything by that -1. And then we're going to add those equations up. And by doing so, you're going to lose one of those variables. It'll be eliminated, hence the name elimination. After you add those equations, then we're going to solve. And usually once you lose a variable, it's a nice, easy equation to solve. And then once you solve for one of the variables, then you can simply substitute to find the value of the other variable. And then you'll have your answer in the form x, comma, y. And you'll be good to go. Okay? So let's do some practice on this. We'll do a couple of examples and then let you go and see what you can do. This first one here, use elimination to solve this system of equations. So if I look at the x's, I've got a 3x in the first equation, a 2x in the second equation. Those are not the same coefficients. But if I look at the y's, I do have the same coefficient. I have a 5 and a 5 here. So I might want to go by eliminating my y's. And then I look and say, are they opposite signs? Yes, they are. This one here is a negative, and this one here is a positive. So I can go ahead and add those up, and I'll be able to eliminate the y right away. So again, what we want to do is we're just going to draw a line here. We're going to add vertically, straight up and down. We're just going to add these up. So the 3x and the 2x would make a 5x. The y's, we've got a -5y and a +5y. Those are going to be eliminated. So we're not dealing with the y's anymore. And then we have to add up these numbers as well. Bring the equal sign down. We got -16 plus 31 would give us a +15. So now we have a nice, easy equation here in which to solve. And we can do that. We would know, we've solved equations like this a lot, and we would divide by 5 on each side. And so x would be equal to 3. So I know right away my final answer is going to have a 3 for my x, but I don't know the y. So I can simply substitute this x in for either one of these equations. And really, it's just, you get to choose what equation you want to substitute it into. I'm going to try to avoid the negatives. Some people like to avoid big numbers. whatever it is. But I'm going to take this second equation here, 2x plus 5y, just so I'm not dealing with negatives, equals 31. And I'm going to take that 3 here and substitute it in for my x. So now I've got 2 times 3 plus 5y equals 31. We know that's 6 plus 5y equals 31. And now it's just a two-step equation. We've solved problems like this all year long. So I'm going to subtract 6 from each side. And now I've got 5y equals 25. And everyone would know, hey, I got to divide by 5 here. Divide by 5. And then y would equal 5. So that would be my y value. So my final answer would be this point, 3, 5. And you could graph both these lines, both these original equations. I'm not going to ask you to do it, but if you did, they would cross at the point 3, 5. That's where that solution gives us a little bit of meaning there. It's just a different way using elimination. Okay? So let's try another one. In this case here, we've got 2x plus 5y equals 6. We've got 2x plus 9y equals 22. So when I look at my coefficients, I've got the same right here with the 2x, but they're not opposite signs. So this is the case where I'm going to have to multiply one of these equations by a negative 1. And I'm going to multiply the second one by a negative 1. But I have to multiply everything by the negative 1 here. Okay? So I'm going to rewrite my equations here. And I'm going to say it's the first one. Nothing changed on the first one. So it's 2x plus 5y equals 6. And the second one now, multiplying by a negative 1, it's going to be 2 times a negative 1 is a negative 2x. 9 times negative 1 is going to be a negative 9y. So we change both of those signs. And we've got a 22 times a negative 1 is going to equal a negative 22. That's the most common mistake, is they forget to multiply the other side by the negative 1 too. You got to multiply everything by the negative 1. So now when we look at this, we can add vertically here, and we can see that these x's are going to eliminate. They're gone. And now we've got a 5y and a negative 9y. Gives us a negative 4y. And then the equal sign. And here we add these, 6 and negative 22, and you get a negative 16. From here, we know how to solve this. We just divide by a negative 4. Divide by a negative 4. And we know that y equals 4. So again, my final answer would have a 4 in it. I know that somewhere my final answer is going to have 4 for y. I know it's not the x value because it says y equals 4. So now I got to find my x. So I can substitute this 4 into any of these equations. So I'm going to use the top one in this case. So it's going to be 2x plus 5y equals 6. And I'm basically substituting this 4 in for y. So now it's going to be 2x plus 20, because 5 times 4 is 20, equals 6. And then it's a two-step algebra problem. I just subtract 20 from each side. So now I've got 2x equals negative 14. And then divide by 2. And my x is equal to a negative 7. So now that would be my negative 7 here for my x value. Again, I could graph those two original equations. I don't want to, because that would not be fun, but they would cross at negative 7, 4. So by using elimination, I found the answer there. Okay? A couple more examples here for you to do. Let's not worry about them, because we did a couple examples. We did an example where we could just add right as it is, and we did an example where we had to multiply by the negative 1 first before we added. And then we also did an example where we found x first, and we also did an example where we found y, so we eliminated both the variables. So not much else changes there. So let's just lesson summary. answer this question: what is the most important thing to remember when using elimination to solve a system? You're going to have some different answers here, but what do you think the most important thing is to remember when doing that? And then the practice problem, I know I've got to change this because this is actually one we already did. So let's do number three from your notes, number 3 practice problem. So I think it's what, 4x plus 2y equals 28, and then 4x minus 3y equals 18. Okay, so let's do that one for our practice problem. So that's it from section 6.3, elimination.